So good day, my young minions. Here's a new video. We're going to call this one Set Theory 4, and it's going to cover the topic of subsets. What's a subset? A subset is where the elements of one set are elements of another set. That's what it is basically in words. So what we want to do is we want to write that out in math notation. So the way we would do that is we would say A is a subset of B if every X an element of A, so every whatever it is, whatever any element of A is also X an element of B. So what we mean by a subset is if we have some element of A, say we have a set A here, and it has some element X, then that X also has to be an element of a set B. So visually this is what it looks like. If A is a subset of B, it's completely contained inside of B. Now of course, if we can say A is a subset of B, then we can also say, we can also have A is not a subset of B. So when is something not a subset? Well, let's take an example. Suppose we have A is equal to the set containing 1, 2, 3, and suppose B is equal to the set 2, 3, 4. Then A is not a subset of B. And why is that? Since, can you see it? Yep, 1 is not, it's not in set B. So since it's not in set B, A cannot be a subset. So to be a subset, every element in A has to also be in B. So since 1 is not an element of B, then A is not a subset of B. And this would be a typical way that you could write some work as well. So let's look at the idea of what we call a proper subset. A proper subset is A is a subset of B. Notice the difference, no line underneath. A is a subset of B if for every X an element of A, then X is an element of B. And if we stop there, that's the same definition as for subset. But we add this, and the set A is not equal to set B, which means they don't have exactly the same elements. In other words, set A has a slightly smaller cardinal number than set B, or significantly smaller, either one. So let me give you an example of a subset and then a proper subset. So suppose we have a set A, which is equal to 1, 2, 3, and we have a set B, which is equal to set 1, 2, 3, 4, and a set C, which is equal to the set 1, 2, 3, 4. Now if we look at this diagram, we can see that A is definitely a subset of B, and we can see that C is also a subset of B. So by definition, every element in A is an element of B, and every element in C is an element of B. But we also C, that C equals B. So C can only just be a subset. However, A is not equal to B, and you could say not equivalent. It doesn't have the same cardinal number. Therefore, this is just a symbol for therefore. Therefore, A is a subset of B. Alright? And when we see it like this, we say A is a proper subset of B. So that's the difference. This means subset, and this means proper subset. So this has some sense that the cardinal number of A is smaller than the cardinal number of B, but also that all the elements of A are still in B. And so just take a peek at those examples, make sure you understand it, and I'll give you a little practice here in a sec. So real quickly, before I give you a couple of examples, it turns out that the empty set is a subset of A for all sets A. In general, except for the empty set, where the empty set is still a subset of itself, the empty set is actually a proper subset of A as long as A is not the empty set. Then the empty set will always be just a proper subset. Okay, you have to remember this. This is very important. Another little known fact in the stuff, and you've sort of seen it up above, but A is always a subset of itself. Okay? Any set is a subset of itself. In fact, sometimes these properties right here are called the identity properties of subsets. They're just things that are always true. So here's a few quick examples. Let's look at number 1 up above. Set of all X such that X is a person living in Alabama, or in B, the set of all X is a person living in the American South. So question, how does A compare to B? Is it a subset? Is it not a subset? Is it a proper subset? So what do you say? And if you put A is a subset of B, that would be correct. If you put A is a proper subset of B, that would also be correct. Number 2. Number 2, the set A is 1, 2, 3. The set B contains the elements 1, 2, 3, 4, 5. So in set 2, how does set A compare to set B? So make sure you pause and answer the question. Yeah, that's right. In this case, you would have also put A as a subset of B, or A is a proper subset of B. So let's look at number 3. So comparing A and B again. So we have the set A, -1, 0, 1, and then we have the set B, the natural numbers. So what would you put in this case? Go ahead and pause. And that is correct. You could have put A is not a subset of B. So those are 3 basic examples, and now I'll give you a couple that are a little more difficult. So here we are at a few more examples. I want you to make sure you pause after each one, and then you pick an answer before you keep watching. So the first one, had to yawn a bit. The first one has, well, let me tell you a characteristic about these problems. The real question on these problems is we're comparing the ideas of is an element of to subset or proper subset. And number 2, we're paying attention to notation. Notation is very important in mathematics, and you have to look at the subtle elements of the notation. And your answers are all going to just be true or false, but be prepared to say why in each case. Okay? So, number one, the set containing 5 is an element of the set containing the set containing 1, the set containing 3, and the set containing 5. So what do you think? Is that true or false? Okay, do you know why? And the answer is that one is true. Notice the elements of our set are actually sets. So we could say that the set is an element of that. It would be incorrect to say it is a subset. And that's really what number 2 is about. So let's look at question number 2. Question number 2 has the set containing 5 is a subset of the set containing 1, the set containing 3, and the set containing 5. So in this case, this is a set over here that has the element 5. So in order for it to be a subset, the elements would just need to be 1, 3, 5 actual elements. Alright, and that's why it was okay to say it was an element, but it's not a subset. In order to be a subset here, I would have needed to add an extra set of braces. The subset of the set containing 5 would be a subset. So the answer here is that one's false, and we've shown you in black how to make it correct in 2 different ways. Okay? If you leave it the way it is, then you would have had to have 1, 3, 5. If you leave the set the way it is, you would have had to have the extra set brackets. Now this is something we talked about today in class, paying attention to notation. And so I'll do this before you have to do this assignment. Well, you guys know I already did because I did in class today. But just pay attention to that as you go through this assignment. It's not just a willy-nilly true-false. You got to look at what you're seeing. Okay? Number 3 says the empty set is an element of the set containing 1, set containing 3, set containing 5. And in this case, this is true. Or, excuse me, pardon me, it is false. Because this is a set of sets, and the empty set is not one of them. Therefore, the empty set is not an element in that case, and that would be false. So now let's go to number 4. Sorry, I was thinking about number 4 when I said true. So the answer to 4 is true. But it says the empty set is a subset of the set containing this. The empty set is always a subset. Notice it's not always an element. Okay? Anyway, I hope that helps. That's the end of the video.